today we are going to talk about how to add and then subtract sets. Before we begin, let's look at something. Assuming I have 4 oranges and I add 2 oranges, I'm going to get how many oranges? 6 oranges. Well, the same thing happens in algebra. If I have 4x and I add 3x, I'm going to get what? 7x. What it means is that I have 4x's and I'm adding 3x's to the 4x's. So I'm having how many x's? 7x. Alright. Then again, if I have 8 bananas and I take away 5 bananas, I'm going to have 3 bananas left. The same thing happens when you come to sets. If I have 4 root 3 plus 2 root 3, because the roots are the same, what it means is that I have 4 of the root 3's and I'm having again 2 of the root 3's. And so if I add 2 of the root 3's to the 4 that I have, I'm going to get what? 6 root 3. What I just did was that I added the 4 and the what? 2. And so 4 plus 2 will give me 6, then you bring what? The root 3. Alright. Then again, if you have 11 root 7 minus 5 root 7, because the roots are the same, we can go ahead and subtract the 5 from what? The 11. So you are having 11 minus 5 will give us 6, then you bring the root 7. So 11 root 7 minus 5 root 7 will give us 6 root 7. The only thing you do is that you subtract the coefficients, the second one from the first one. Alright, but let's look at something. Assuming I have 10 oranges, is it possible to take away 5 bananas from 10 oranges and get a single item? No, that's not possible. And also, if you have 25 oranges and you add 5 bananas, it's never possible to get a single item. But you agree with me that if I have 25 oranges in a box and I add 5 bananas, I'm going to have 25 oranges and 5 bananas. It can never add to give a single item, like 30 oranges, bananas. No, there's nothing like oranges, bananas. And so the same way, in this case too, I'm going to have 10 oranges minus 5 bananas. This can never add up to give me a single item. The same thing applies to set. If you have 5 root 6 plus 8 root 2, because the roots are not the same, we cannot say we are going to add the coefficients or we are going to add the rational part. And so it remains the same. You cannot add them to get a single root, and so it remains the same. Same thing applies if you have 7 root 3 minus 4 root 5. Because the roots are not the same, you can never subtract them, and so you are having the same thing. 7 root 3 minus 4 root 5 is equal to 7 root 3 minus 4 root 5. Don't even worry yourself. And so we can conclude that only like sets can be added or subtracted. Only like sets can be added or what? Subtracted. Unlike sets like this can never be added to get a single unit. So in general, we can say if you have m root k plus n root k, it's going to be m plus n root k. You're just going to add the coefficients, then you maintain one of the roots. Likewise, if you have m root k minus n root k, you can guess what it's going to be. Yes, you're right. You're going to have m minus n root k. And so these are the basic addition rules that will guide us to be able to perform addition and subtraction in sets. Let's look at an example. If I have root 50 plus root 8, you agree with me that these sets are not in the simplest form. Unlike these ones without weight, they are all in their simplest form. So then we have to reduce these sets to their simplest form before we go ahead and add them. Alright, so for the root 50, I'm going to have root 25 times 2. And then plus root 8 is root 4 times 2. Good. Then you go ahead and each of them takes the root sign. The root 25 will take the root, this one will also take the root, this one will take the root, this one will also take the root. So we have root 25 times root 2 plus root 4 times root 2. If you are familiar with the system, there's no need to worry yourself about this step. Then root 25 will give me what? 5. Then you bring the root 2 because it's already in the simplest form. You cannot do anything to that. Plus root 4 is equal to 2. Then you bring the root 2. Now both of them are in the simplest form, so we can go ahead and add them. And because the roots are the same, means they are like sets, so we can add them and say we are going to add 5 and 2. So 5 plus 2, then you bring the root 2. Then 5 plus 2 is giving me what? 7. Then you bring down the root 2. This is your answer. Let's look at a second example. Assuming I have root 500 plus root 45 minus root 125. These roots or these sets are also not in the simplest form. So we have to reduce them to the simplest form before we go ahead and add and subtract. Root 500 can be written as root 100 times 5. 100 is the perfect squared. Plus root 9 times 5. Root 45 is the same as root 9 times 5. Minus root 25 times what? 5. 25 times 5 will give us 125. Then we go ahead and each of them takes the square root sign. Root 100 times root 5 plus root 9 times root 5 minus root 25 times what? 5. You can skip this step if you are familiar with how to go about it. It doesn't matter. You can decide to skip this step. Yes. Root 100 will reduce to what? 10. Then bring down the square root 5 because root 5 is already in the simplified form. You can reduce it further. Then root 9 will reduce to what? 3. Root 5. Then root 25 will also reduce to what? 5. Then you bring down the root 5. Now this is in the simplest form, so we can go ahead and add and subtract the coefficient. So now we are going to add 3 to 10, then subtract 5. Alright, so you have 10 plus 3 minus 5. Then you bring the root 5. Okay, because they are like sets, we can add and subtract their coefficients. Alright, so this is going to give us 8, then you bring down the root 5. That's your answer. Isn't it simple? Good. Let's look at the last example. If you have 5 root 24 plus 11 root 7 minus 3 root 6. You see, if you look at this set, you check whether they are all in the simplest form. If not, then we have to reduce them to the simplest form before we proceed. When you look at root 24, it can be reduced further. But when you look at root 7, it's in the simplest form. You look at root 6 too, it's in the simplest form, so we can't reduce it further. So these two are already in their simplest form. But when you look at root 24, we have to reduce it further. Okay, so can you write this first term in this form? 5 root 4 times 6. 4 6 is what? 24. Then we bring down the other ones because they are already in the simplest form. Alright, let's simplify this further. You can go ahead and write this in this form. Then bring down the other ones. You can decide to skip this step if you are familiar with how to do these things. Then again, we can write root 4 will reduce to what? 2. Root 4 is the same as 2. Okay, you bring the other terms. Then the 2 will multiply the 5. The 2 will multiply the 5, of course. So you have 5 times 2 root 6. So 5 times 2 will give us what? 10. So you have 10 root 6. And you bring the other terms. Now you see that we have 10 root 6 plus 11 root 7 minus 3 root 6. These two are like sets. You see that? Good. So we can go ahead and rearrange this to have 10 root 6 minus 3 root 6 plus 11 root 7. So we can go ahead and then subtract these two. You can subtract 3 root 6 from what? 10 root 6 because they are like sets. Because the roots are what? The same, so we can subtract them. Alright. We are getting 10 minus 3 root 6 plus what? 11 root 7. Then this one will reduce to what? 7 root 6 plus what? 11 root 7. That's your answer. We cannot add this to that. We cannot add 11 root 7 to 7 root 6 because they are not like sets. And so this is your answer. Alright. Thanks for watching. And I'll see you in the next section where we talk about multiplication and division of sets. So stay tuned and I'll see you in the next lesson.